Hello YouTube, Gadget Boy here, and we're here with another kit build. This is an early Christmas gift that I got from my boyfriend a couple of days ago. Well, actually, I think it's been a little over 2 weeks now. And I have absolutely no idea what it does. He just handed it to me and said, "Make this." And I said, "What does it do?" And he said, "Well, you have to build it to find out." So there's absolutely no indication on the packaging what it does. The little Ziploc baggie that everything was kept in has the part number for a triple nickel timer and a 4017 decade counter, which gives me some indication of what this is going to be doing. It's going to use the triple nickel timer to send a pulse into the decade counter, which is then going to count, and I'm assuming illuminate LEDs in a sequence. But that's just a guess. Now this is going to be a little bit of fun. We did a surface mount project a little while back. This is also going to be a surface mount project, as you can see by the little ammo belts here. And in this case, we're going to have to surface mount some integrated circuits, or ICs. So just a quick rundown of how to identify surface mount components. We have here marked on the board, thank goodness, because there's no schematics, that we need 1K resistors, 10K resistors, and 2K resistors. So a 1K resistor on a surface mount component is going to be notated as 102, because you're going to have a 1, a 0, and then 2 zeros, so 1000. And then a 10K is going to be 103, a 10, and then 3 zeros for 10K. And a 2K resistor is going to be 202 with 2, 0, and then 0, 0. The only other component we have to worry about identifying, well, there's actually three, is the capacitors. We've got a 1 microfarad capacitor there and a 1 microfarad capacitor there. I think one is acting as a decoupling capacitor of some sort, possibly, and the other is going to be acting as the timer capacitor for the triple nickel. When I say triple nickel, I mean a 555 timer, and that's just what my dad used to call them, was triple nickels, because it's a little easier to say than 555. And then the other two components we have to identify are the triple nickel timer, which is this 8-pin chip, which says on it NE555, and then the decade counter, which is right here, which says CD4017. And those are of course marked as well on the board. And then we've also got a little 50k ohm trimpot here, which is more than likely going to determine the speed at which the LEDs chase, because I think that's what they do. And then of course we've got some LEDs. I'd meant to do it with blue LEDs, but I didn't buy enough blue LEDs off the bat, so we're just going to do it with red LEDs first, and then I'll probably do a quick little follow-up video of it being done with blue LEDs. So, well, actually I'm going to mount one of the ICs just to show you manual soldering techniques for surface mount integrated circuits. Is rather challenging to do these by hand, so we're just going to peel that open and grab this little circuit out here. Oops, I'll just grab it with my fingers there. So pin 1, I don't know if it shows very well on the camera, but there's a little divot on the chip here. That's going to be pin 1, which that little divot is going to correspond with the divot on the circuit board here. So I'm just going to rotate that. Actually, how is best to do this? we'll have to experiment and see. So anyway, I'm going to grab my new soldering iron here. This claims to be a Yihua 995D soldering rework station. I bought it off of AliExpress. I'm pretty confident it's a counterfeit product because it just doesn't feel like a real product, and the cables, which are supposed to be silicone sheathed, are rubber sheathed instead. And there's just some other quality indications that lead me to believe that it's fake. So be careful when you order things off of AliExpress. Anyway, we're going to give it a try anyway, just to see how it performs. Now I bought a nice, really super fine tip, or super fine soldering iron tip here to work with surface mount components like these, and we'll see how that performs. Now I'm just going to quick swipe some resin or flux onto these pads here to help flow the solder. And we're going to start by flowing some solder onto one of the pads, just one. Then we're going to grab this IC with the tweezers, and we're going to melt that solder again. And just kind of try to monkey the IC into position here. And see if that, actually, that didn't seal that pin down very well. So we'll dab a little bit more flux onto it. And there we go. So once we've got that one down, I'm going to quick flip it around, rotate it, and tack the opposite corner down. In the hopes that it holds it down, and then we can proceed to very carefully solder the remaining legs on. I'm going to cheat a little bit here and just dab solder onto the tip of the iron and then touch it to the legs of the integrated circuit here, just like that, and let them suck the solder off of the soldering iron. There are a couple of different techniques you can use to do this. This is the one that I've found in the past to be most effective. So we'll just wet that down with a little bit of flux. And then we'll fluff some fresh solder onto the tip of the iron there. And then just float onto the board, like so. The flux is a very important component when you're doing this because you want that solder to flow as easily as possible onto those pads and the legs. And there we have it. First side is a little bit messy. I'm going to clean that up with a little bit more flux here. Ideally I should have a can of flux cleaner spray, which is basically just you hold it over a trash can and spray it with the flux cleaner spray and it washes off all of the excess flux. But I don't have that. Anyway, so that's how you manually solder a surface mount IC. It's one of those things that you can't really do without a ton of practice. So we'll just go into time-lapse mode now, and I'll throw the rest of this together, and then we'll experiment with figuring out how much voltage to give it. So I'll be back in a bit. Alright, and we're back from soldering all of the surface mount components. I forgot to mention that the capacitors have no notation on them. They're just these sort of little brown boxes with silver ends, so you kind of have to take it on faith that they are the value that they're supposed to be. Thankfully, they're the component values for the capacitors are both the same, so I didn't have to worry about figuring out which was which, because it's pretty much useless to try to read one of those with a multimeter. Anyway, so moving on, we're gonna actually I think I want to switch to a different tip here. So I'm going to do something a little strange here and change tips while they're still hot, which is a perfectly okay thing to do. It's just a little challenging. The more and more I work with this soldering iron, the more convinced I get that it is counterfeit, as I'm noticing that the handle of the soldering iron is not made of heat-resistant plastic, which is a little dismaying. So I'll probably swap the handle out for the good handle that I've got. Actually, really pretty upset about the soldering iron being counterfeit. I was really excited to have a good soldering station, and my hopes were dashed by Chinese counterfeiting. And you know it's bad when the Chinese are counterfeiting their own products, because Yuhua is a Chinese company. But anyway, enough about that. For actual performance, it seems to do the trick. Although one of the big selling points of this particular iron is that it's got a Samsung CPU in it. Somehow, I doubt this one has that Samsung chip in it. I'll probably actually open up the case and see for sure what's inside. For all I know, the display and the buttons don't actually do anything but beep. So that'll be a thing to find out in time. So all I'm doing here is I'm mounting the power pins. Nothing overly special there, just a couple of 90-degree angle terminal pins. We'll solder them on like so. Interesting buzzing noise coming from the soldering station. Anyway, And then the last part is going to be the LEDs. I will go back into time-lapse for that part and see you in a few minutes. Alright, and we're back. Some time has passed since I actually finished because I needed to find some various bits and bobs that I needed for the next phase of this. So I'm going to assume that it runs on 5 volts. It's got 2 logic level chips which run off of 5 volts. And it's got a bunch of current limiting resistors which should also help it run at 5 volts. So what I've got here is just a little battery pack with a USB cable and a little pinout header that's really useful for diagnosing problems with USB devices. So I'm just going to take these little wires here and put them to the VCC and ground, which is plus 5 volts and minus, basically. And then we're going to put the white wire there for the plus and the black wire there for the minus. And then we're going to press the power button on this little battery pack here and see what happens. Hey, look at that. It does exactly what I thought it was going to do. Now, if I grab this screwdriver here, oops, let's use this one. I have a proper screwdriver for adjusting a trimpot somewhere around here, but I can't seem to eyeball it. Anyway, oops. Well, that's interesting. It's not pulling enough current to actually keep the thing on. So if we adjust this 50k ohm resistor, it slows down. And if we turn it in the other direction, it goes really fast. So there we have it. A whatever the heck that is. So I hope you've enjoyed watching this kit build. If you liked it, hit that thumbs up button, share it with your friends, let them know about my channel. Really hoping to get 100 subscribers so I can get my custom channel name, maybe by Christmas, you know, possibly. I hate begging for subscribers. I feel like such a tool doing that. Oh well. Anyway, I will see you all in the next video. Bye-bye.